All right, here we are again. Now I'm going to show you some problems from section 2.8, graphing linear inequalities in two variables. I promise this is the last video today. We did a lot of practice graphing lines. Well, we'll use that now because when we look at a linear inequality, we have to graph the boundary line, which in this case would be y equals -2. Now let's refresh our memory on inequalities when we're doing this. If we have a strictly greater than or less than, the line you graph will be dotted. If we have less than or equal to, greater than or equal to, it'll be a solid line. So y equals -2 is a horizontal line at -2. This is strictly less than. So it'll be right here. So how do we decide which side of this line to shade? Well, we have to try to figure out where, which side is the solution set. In this case, if I look at this line, y equals -2, right? And I say y is less than -2, well, less than y is down here. So I think I'm going to shade this side. But I can always test a point. The easiest point to test is 0, 0. Now, based on what I shaded here, I do not expect 0, 0 to work. Okay? So what I do is I take my test point and I plug it in to this inequality. In this case, I only need the y. So what I'm saying, 0 is less than -2. Is that correct? Well, no, it's not. So we did shade the correct side. Since it wasn't true, we know that 0, 0 is not in our solution set. The other side of this line down here is our solution set for this particular inequality. Okay? Let's look at another one. Now, again, we have to graph this line. Oops. Let's make this a greater than. We have to graph this line, don't we? The boundary line. If it's greater than, strictly, it'll be a dotted. So we could either graph this line using intercepts, or we could solve it for y equals mx plus b. Let's do that. So I'm going to subtract 5x from both sides. So we have -2y is greater than -5x minus 4. All right, I need to divide by -2. Everything divide by -2. Now, when I divide by -2, folks, I have to flip that inequality symbol, don't I? So this becomes y is less than -5 over -2. So 5/2 x minus 2. I can graph this line, right? -2 is my y-intercept. 5/2 is my slope. So I'll go 1, 2, 3, 4, 5 over 2, right? I have a positive slope there. So here is my line, my boundary line. So now if I read this out loud, it says y is less than that line. All right, I'm guessing this will be the side I shade because it's really lower and less than along the y. But let's test a point. Let's test 0, 0. I plug it into the original. I say, is 0 greater than or equal to 5/2 times 0 minus 2? So is 0, I said greater than, is 0 less than -2? It is not. So this side over here is not our solution. This side to the lower right is our solution set. All right, one more. All right, now I have y is greater than or equal to -2/3 x minus 2. All right, it's a greater than or equal to, so it's a solid line, isn't it? And this is already in my y equals mx plus b form. So I'll graph the -2 as my y-intercept, and I'll use my slope, -2/3. So up to -2/3, 3. Okay, it's a solid line. Now I'm going to read this out loud to myself. y is greater than this line. So I think greater than is up, right? Up along the y-axis. I think this is the side, but I'm going to test 0, 0. Now in this case, I think 0, 0 should work because it's on the side I think is the solution set. So let's plug it in. Is 0 greater than or equal to negative 2/3 times 0 minus 2? Is 0 greater than or equal to negative 2? Yes. So this point works, and we have indeed shaded the correct side. All right? This is a useful video to prepare you to do some of these problems for homework. All righty. Thank you.